Hey, I am Gopinath, Program Manager in Visual Studio Team Services. Today we will be talking about the continuous testing in team services. First, let me talk about the industry trends. Everybody wants to ship faster with increased customer value, and they want to maintain the quality bar or in fact higher quality bar. The next thing is developers want to use modern methodologies. They want to adopt test early, test often. They want to adopt continuous integration and test on a continuous basis. Third thing is they want to optimize the resources. Leverage cloud as much as possible so that I can offload all of my testing to the cloud and focus on the feature development. Now, before I get on to the testing part, let me just give a quick introduction about Visual Studio Team Services. Visual Studio Team Services is all about application lifecycle management solutions available for you, where you can just use code for all your source code management, work item or issue tracking, continuous integration, release management, testing, packaging solutions, all available in a single place. That's what is Visual Studio Team Services. Visual Studio Team Services is a SaaS offering, software as a service offering. We also have an on-prem solution available, which is a Team Foundation server. So this is how the page looks like, where home is where you can pin the dashboards, you can see the overview of what's going on with respect to my team, you can see how many total bugs are there, what work items that are important, you can track all of those. Code is where all the source code is going to sit on, work is the issue tracking system, build is the continuous integration system, and the test is where all the test execution will happen. So this is the team services. Now let me just switch back onto the slide and then now go about what does continuous testing in team services mean? What value propositions that we provide to you all? The first thing is, in continuous testing, you can test any application on any platform. You can bring in Java application and then test it. You can bring in .NET application and then test it. You can bring in your Android application and then test it. You can even bring in your JavaScript solution and then test it. So essentially we have built-in tasks available, build steps that are available for you to build and test any of these applications. The second biggest thing is actionable test insights. Test is never complete without providing a good reporting story. You execute the test, you want to provide a really actionable test insights so that you can take the steps appropriately. For example, in team services, we provide, once the test execution is complete, clearly highlight what are the new tests that are failing in this corresponding run, so that as a user, I can actually look at the new failures and then investigate quickly the regressions and then debug them a lot more faster. That's one example of actionable test insights. This platform is fully extensible. If your enterprise is using your own custom test execution, we have extensibility available. You can write your own task and then plug it into the system and execute it. Finally, we have testing is fully integrated into the team services. You can integrate with the continuous integration for build. You can integrate with the release management so that you can test your product just before it goes to the dev environment or a QA environment or a release environment. It is also integrated to convert your test failures quickly into issue tracking or work items too. So that's about the continuous testing. The next, I will actually show you a series of demos to show all of these capabilities. Next, let me just show you the Java application testing. What I'm going to show is from ground up, pick up a Java application and then show you how do I configure a continuous integration for Java for building it and testing it on a continuous basis. Let me just quickly switch to my demo view, and in the demo view, let me open the, so this is my Visual Studio page, just like what I have shown before, the Visual Studio Team Services, the Code Hub, the Work Hub, the Build Hub are all available. And let me just switch on the build. So today I have already checked in my code into the system. So source code is already available in this. You can actually see the source code available here. I just opened this page up front. The code page is available. Now in the build, I'm now starting from scratch. I would like to create a new build definition. So I pressed on the plus button. Now out of the box we have build templates that are available. You can create a Windows Universal application, you can create a MS build application, you can create Xamarin or Xcode. Any application that you want to build and test is supported. By default the templates are available. Let me start with an empty template, and now the source code control system is completely pluggable. You can come from Subversion, you can have your code stored in GitHub, or you can store your code just like the way I have stored in my system itself. So currently the code is stored in the VSTS team services system. So I will just use that and then use the master branch. Now I'm creating an empty build definition, so it doesn't have anything. So what I would like to do now, let me just click on the build step. Now the code that I have already has a Maven build file that's available. So when I just click on add build step for configuring continuous integration, you will see a lot of built-in tasks that are available. You can build Android, you can build Ant, Gradle, Grunt, Gulp. So this is exactly what I was talking about. You can have a Java application, a .NET application, Android application, Xcode application, or JavaScript application. All applications are supported in this. For this particular demo, I will choose the Maven. Let me add the Maven task. Now in the Maven task, given the code is available in this, I can directly browse by clicking on this button. When I just clicked on this button, it will actually start showing me what source code is available, and I can just choose the build files that are needed. I have a Java example, and then I have a POM file that is available here, which is used to building the Java product code and the test code, and it also can run the test too. So I picked up the POM file, and then I'm now just saying that, hey, I want to publish the results to TFS or team services once it is complete. I will also choose the code coverage. By default, we already have Jacoco and Koberchera code coverage solutions available. So for this demo purpose, I will just choose the Jacoco, and now almost your build step is ready. Let me save it and then configure it as my Java CI. The last step that I would like to do is I'll go to the triggers and then configure continuous integration for it. So what does continuous integration mean? Continuous integration, for every change that gets submitted to the master or that gets committed to the master, the build definition that I have shown will get triggered. So it will actually do a build, and it will do the test, and then it will publish the results. So this is how it will help you to do the faster testing. So I will save this. Now I can actually manually queue the build, or I can actually do a code change and then let it trigger this. Let me just go to the code. This is the source code that's available. I would now like to force a test to fail so that I can actually see it. So I have this test expression 4. I'm now just going to make it to fail. Convert 16 to 14. Let me edit the code and make it 16 to 14, and I'm just directly saving it here. So now the code change is saved. If I go back and then see in the build page, you should actually see a new build definition that will get triggered because of this. So there you go. So this is the code. This is the commit I just did. Because of my commit, the build has just started. I can actually click on it and then see the console output of the build. Currently my build is waiting in queue. Now while it is waiting in queue, let me actually show you the execution that I have done before, and how does it look like, and then what exactly are the results that are available. This is the build that I have just done before the demo once, and as you can see, the build is done. There are Maven step was the one that I have included it, and the Maven, it failed today because there are a bunch of tests that I forced them to fail. We clearly show as part of the test results how many total tests are there, how many are passed and how many are failed. And in the failed test, we actually highlight new tests and existing tests. This is what I was talking about, the actionable insights. The new tests are very clearly shown as regressions, and the existing tests are the tests that have been there before. And we also show you how much pass percentage, is it going up or is it going down. In addition to that, the code coverage results are also shown very clearly with respect to branch coverage, class coverage, complexity. Depending on the code coverage tool you have used, it will plug in and then show you the results. So this is what I mean by actionable test results. If I actually click on the test, I will be able to now see a little bit more detailed. The good thing about this is you can see by default all the failed tests, because that's what you want to see in the continuous integration. Now the current build is 143. This test has been failing in 142. What you can now do is you can actually go click on, oh, there are 4 failures, some of these failures have been for a while. You can go click on this 142 and then see what all code changes were done in that corresponding build, and then you can investigate and then identify the issue a lot more faster. This is what is all about actionable test insights. Now let me just switch back and then see. So this is what the view that you will get. This is the build that is executing currently. It is showing me the live streaming of what exactly is happening while the build is executed. So in summary, what I have shown you in the Java demo, I just had my source code available. I did not set up any build machine. I did not set up any test machine. I was able to create a simple continuous integration build definition, configure it with the source code, with the code coverage, without any build setup, and then execute completely using the cloud systems that are available. The coolest thing about this is, so now let me switch back. The next thing that I would like to show after Java is the .NET application testing. So as I talked about, we support every application testing. It can be Java, it can be .NET, it can be JavaScript. Now as part of the .NET application testing, I would like to now highlight and then talk to you more about the Selenium testing. How do we do the Selenium testing, or how do we do the testing in the Azure cloud? So those are the 2 things that I would like to highlight. Now to show you the Selenium testing, I already have a Visual Studio solution that's available. Here is where there are tests that I have created, and you can see in my solution there are all the, in the test explorer you are able to see all the Selenium tests that I have written, and then there are a bunch of unit tests that are available as well. So let me enable these additional unit tests that I would like to submit to the system. And I'll save it, I'll build it, it will actually now show me all the tests that are available in this. Now what I would like to show you is, show the build definition. So this is the build definition that I have, which actually just like the Java build definition, first one is it's doing the build, second one is it is doing the web application deployment to the Azure cloud, because what I have built is a ASP.NET application. Next one is the Selenium testing, right? I have written the Selenium test. Now these tests are targeting the system, and then it will run test, and then it will report the results back. So these are the 3 tasks that are available. If I want to add another task, for example, I want to also do unit testing as part of it, after my build is done, I can just add a unit testing task as well, and then I can move this task correctly so that it can do the required unit testing. Now let me just, because I named my unit testing DLL as, I named it as web app unit test, I will just call it as web app unit test. So that's it. Now my solution is ready. Just like before, if I configure the continuous integration, I can actually now go submit my code change from Visual Studio, and it will actually trigger it. Let me just go, because I have commented couple of tests, I will sync, and now I will pull, and Let me just enter a commit, added a new test, commit this. Now after this, let me just sync and then push the code changes. So, this now will automatically push my updated code into the repo. This again should trigger another build for .NET. Let me just click on the queued. There you go. So, this is the build that I just committed, and now the build will trigger. So, this is how I can do Selenium testing. Now, after the test is done, how does the results look like? So, just like the other one, here are the results that I have executed before. It will actually give me a detailed report. If I click, I can very clearly see what tests that are passing, what tests that are failing. I have Firefox test, I have Chrome test, I have click application name Chrome test. All of these tests is what I have executed. Once the test execution is done, we have dashboards that are available. Assume if there are tests that have been failing in some other builds, assume in this case I'll just click on it and I can take it and then pin it to my dashboard so that I can monitor the quality of my build on a continuous basis. If I now actually go to a page of this overview, I will be able to see the page that I just pinned and then monitor the quality on a continuous basis. So, I am just navigating to the home. I pinned it on my overview page. Yes, this is the overview page. There you go. So, this is the BDD Selenium dashboard that I just pinned, and from here I can monitor it and I can actually navigate. Let me just see one of the runs that has failed. Let me navigate there and then see what's going on. In this test, if all the tests in this particular test, all the tests have been failing, assume I do the investigation. Now I want to file a bug for it. I actually take this, click on this create bug icon. It will take all the metadata related to the test and then file a bug. This is what I call it as a grade ALM integration, right? So, you want to just to take the test failures and then easily convert them into the issues. When I save this, it will take all the information, keep it there, and it will also create the bug here. So, that next time anybody whoever comes at it, they can look at it and then they can see the quality, they can see the current status of this bug and then take the appropriate action. In fact, if a developer wants to investigate, he can go to the links, and the links, the build is available and the test result is available for him to go deeper. So, this is the first part of how to do Selenium testing. This is same Selenium testing is available for .NET applications or even for Java applications. In the demo, what I have shown you is for .NET applications. Same thing will work for Java, JavaScript. For that matter, given that the Selenium is cross-plat, it will work for any web application. The next one that I would like to talk about is how do I make use of the cloud so that I can dynamically provision machines and then deploy my application to the cloud and then run the test in the cloud. So, that's the next demo that I would like to show. To show the demo, let me switch to my environment that I have already created. So, here is the build definition that we already have. Now, in this build definition, the first step, all it's doing is it is building the test code. The second step is the important one. In the second step, we are actually creating a Azure connection because I am trying to leverage my Azure machines for all my remote testing. So, the scenario can be, oh, I want to deploy my web application, but I have a lot more tests to be run. Now, instead of me running Selenium one by one, I want to run them on more machines so that I can do the execution lot more faster. Or you have a client application, now you want to test your client application on Windows 8, Windows 8.1, Windows 10. You want to cover a configuration of matrix for you to see the quality. That's another scenario for it. Now, in this scenario, you want to deploy your application, and once the application is deployed, you want to copy your test code to these set of machines and then run the test. So, as you can see in this, what we are doing is we already have Azure subscription that is available. We already created a set of machines in the cloud. Now, I am just taking those machines as an input here, by saying that, oh, you know what, these are the resource group that I want to use. If there are more resource groups that are available, you can actually choose them here. Take the resource group appropriately, and now there are multiple actions that are available. You can actually, for this resource group, just select the machines that are available in the resource group, or you can start the virtual machines, you can stop the virtual machines. The power of this is, when you want to deploy your application and then dynamically provision the machines, run your test. Once your tests are done, you can actually shut down all of the machines, so that you can actually save money, instead of you can just pay for whatever you have used. So these are the test tasks that we have. What I have shown you before is a simple Visual Studio test task. What you have to add for running test on cloud or on remote machines is Visual Studio Test Agent and run functional test tasks. These are the two tasks that you want to add to your build workflow for you to run test remotely. And for both the tasks, you are actually giving input on what machines you would like to target, and once the agent is installed, in the run functional test, you actually take the same resource group, and then you will say, here are the list of assemblies that I would like to execute, and it will automatically pick up these machines and then execute the test. And when it comes to the reporting format, it actually gives you the exact same reporting format, and you can actually even gather code coverage information as well when you are targeting the remote testing. Finally, what I have shown you is this testing, it can be done even in the build workflow, or people can do all of the functional testing in release workflow as well. Build, you will primarily use it for continuous integration. You want to do it for every check-in. Release, you primarily want to deploy it to your dev environment, QA environment, and do all the functional testing. Here is a simple example that I already created, where I have 3 environments. One is a dev environment, QA environment, and a pre-production environment, where I'm actually creating machines dynamically. I'm doing a SQL deployment, and then I'm executing Azure PowerShell, and then I'm running the smoke test targeting it. So this is how you can just do the functional test. You can also do cloud-based load testing, because you have a web application. You want to make sure that in the QA environment, if I increase the load, is my application performing properly or not? You would like to validate that. We have, in our continuous testing solutions, we do provide load testing by providing a task for running the test in the pipeline. So that's the summary of .NET application. I was showing you how to do the Selenium testing, and how do I take advantage of the Azure cloud for me to do the test execution lot more faster with more machines. Finally, the last part that I would like to show is mobile application testing. Now, as part of the mobile application testing, the key thing is, today from Microsoft perspective, we have a partnership with Xamarin, Perfecto Mobile, and Sauce Labs. So there are extensions that are available. The task workflow that I am showing here is fully extensible. If you actually go to the build task, you can see in the test, you can actually see the Perfecto Mobile task being available. You can see the Xamarin Test Cloud available, and any task that you want, you can actually bring it on and add it to the system, and it is fully extensible. So if you want to do a device application testing, here is a simple workflow that we have created. What we have done is, we have created a iOS application. That's the IPA file that we have. You can run the iOS application. You can build the iOS application, and once the build is done, you can actually upload it to the Perfecto Cloud, and you can run the test. So in this case, the tests are written in Java because they are Appium tests. Now you are able to execute Appium test in our workflow, and once they pass on iOS, we are exactly doing the same thing for targeting a bunch of Android devices as well. So let me just see how the output looks like, and then what all I can do, how powerful this is. For example, the report looks the same, but the cool thing is, if I actually go to the artifacts and then download the artifacts, I have more details available in this. So this one is executed on Perfecto, and if you actually see the report on the Perfecto, it will actually tell you what all tests are run, which test has failed, along with the screenshots. So it's very, very easy for you to investigate if there are test failures in the system. So that's the mobile application testing. So what did we cover until now in the demos? We covered testing Java application, testing .NET application, testing mobile applications. So it means I can test any application on any platform. We are truly cross platform. You can use Java tests, you can use JUnit test, you can use NUnit, XUnit. We support every test framework that is available to integrate into our system. We also talked about the actionable test insights, where instead of just showing the results, we actually highlight the actions as a developer that you can take. So it's easy for you to identify new tests or existing tests. Finally, our platform is fully extensible. You can bring in your own custom tools, custom test execution, targeting your custom platforms, and then push the results using a publish test results task that is available. And we will light up the remaining workflow once you push the results. Finally, we have full integration with the team services. You can do continuous integration, testing in continuous integration, testing in release management, and then we have integration with all the work items. So if you want to get started on it, these are the two links that are available for you to help. You can go to akka.ms.devops test. It will automatically take you to the sign up page. You can sign up and then try it out and then give us feedback. And if you want to more content, more videos, go to the content link. You will be able to see bunch of videos with respect to manual testing, load testing, in addition to the Java.NET testing that I talked about. Thank you. If you have feedback, please reach out to me. Thank you.